Welcome to Brain Vision.
In this question, we have a sound source that operates at a frequency of 2 kilohertz and a power rating of 20 watts, and it emits a sound uniformly in all directions. The speed of sound is given as 340 meters per second, and the density of air 1.2 kilograms per meter cubed. And we're asked to find a variety of different quantities. So in part A, we're asked to find what is the intensity at a distance of 6 meters from the source. So there's lots of givens in this question and lots of things to find. So I think in particular, we really want to focus on writing down our givens and making sure we know what those are. So we've got 2000 hertz or 2 kilohertz for the frequency. We know that the power is 20 watts. And we also know the speed, so that's going to be 340 meters per second. And then finally, we know the density as well. And in the first part, we're told that it's at a distance of 6 meters, and we would like to know what the intensity is. So since we know the power that the source is emitting, we can easily calculate the intensity because that energy is going to spread out over a circle of radius r. So the intensity is equal to the power, the power divided by 4 pi r squared. So we're just going to plug everything in. So 20 watts divided by 4 pi, 6 meters squared. So that's going to give us an intensity of, 0.044 watts per meter squared. So that's our intensity. So that's the final answer for part A. Okay, and then we'll go on to part B, where we're asked to find the pressure amplitude at the point 6 meters away from the sound source. So now we're trying to find the pressure, which is a small case P. I'm going to put P naught just so we can be very clear about the different P's going on here. And for this, I'm going to just merely use the formula that relates the intensity to the pressure amplitude. So intensity is P naught squared divided by 2 rho V. So we can go ahead and rearrange that. That's going to be P naught is the square root of 2I rho V, and I'll just go ahead and plug everything in here. So we've got the intensity from the previous part. The density was given in the question, and then also given in the question was the speed of sound. So we can go ahead and calculate that. Okay, so we get a pressure amplitude of 6. And if you work out the units, that's going to be in our standard units for pressure, so 6 newtons per meter squared force per area. And so that's our final answer for part B as well. Okay, and then we go on to part C, where we are asked to find the displacement amplitude. That's going to be S naught as given in the textbook. And we do have a formula that relates the pressure amplitude and the displacement amplitude. But this requires us to also know K, the wave number, and B, the bulk modulus. So let's focus on getting those first. So K, the wave number, we know that's going to be 2 pi times the wavelength. Oh, sorry, that's 2 pi over the wavelength. We don't know the wavelength, so I'm just going to go ahead and rewrite that in terms of the speed and the frequency. So we know that, I can maybe just do this on the side here. So we know that V is equal to lambda F. So we're trying to replace 1 over lambda because lambda's on the bottom right now. So we can divide by lambda. So it's going to be F over V. Okay, F over V. That's going to be our wave number. And then once we get that, I will show you how to find the bulk modulus as well. The frequency is 2000. And then the speed is 340. Okay, so let's do that calculation. Okay, so we get a wave number of about 37. Okay, for the bulk modulus, we know we can relate that to the speed using this formula. So if we square this, we'll get v squared is b over rho. So b is v squared rho. So it's going to be 340 squared meters per second squared times 1.2. So let's see what we get for that. So the bulk modulus is about 139,000. Okay, so what we can do is plug those two numbers back into this formula that I wrote up here. And solve for S0. So sorry, I'm just going to write in the P0 that we found, which was 6. Okay, so I'm just going to divide both sides by those numbers. And we get a displacement amplitude of 1.2 times 10 to the minus 6. And that is in the standard units of meters. So that is our final answer for part C as well.